Hey guys, sorry I'm not there today. I hope you had a great weekend. Today we're gonna review what we talked about on Friday, which was rate of change. We're gonna attach that to slope, which are actually very similar. Um, to get us started, let's do a quick review of what we did on Friday. On Friday, we've learned how to find the rate of change from a graph and from a table. Let's look at this graph here. One thing I meant to do, and I forgot to do, is that graphs tell stories, right? And I forgot to put labels on our graph here. So here's the thing. I was watching this kid, and I started to collect some data, and our x-axis, x is often time. This is going to be the number of hours. Our x-axis is going to be the number of hours. I was watching this kid, and the y-axis, this is boogers eaten. Gross, right? It was a little kid. It wasn't a high schooler. Anywho, back here. The way we find the rate of change is by finding the rise over run. But actually, sorry, let's start here. Let's start with the starting point. Where does this graph start? Well, the starting point is where it intersects with the y-axis. And at this point, at 0 hours, when I had starting to collect data, this kid had already eaten 7 boogers. That's disgusting, right? Anyways, the starting point is where the graph starts. It's the y-intercept. But the rate of change, remember, that's where we find the rise over run. Now look at this line. From left to right, which way is this line going? It's going down. So right away, what kind of rate do we expect to find? Positive, 0, or negative? It should be negative because it's going down. Now, we talked about how rate of change is rise over run. Oops. What just happened here? I always have issues with this. What? Oh my goodness. Is this working yet? Rise over run. All right. Sorry about that. Always something, right? So, check this out. To get from this point to this point, we got to go down some and over some. The rise, it went down 2. So we got our negative. So it went down 2, and it went over 1, 2, 3. Now, the thing though, it went down to what? Well, it went down 2 boogers and went over 3 hours. So the rate of change here is negative 2 boogers every 3 hours. So every 3 hours, this kid is eating 2 less boogers. I suppose that's good, that at least he's decreasing this behavior. But, yeah, it's going down. It's kind of gross. Hey, Smith, I didn't like those 2 points. What if I picked this point and this point? Check this out. Even if we did that, it's still negative, right? It's still going down. But in this case, if I went with these 2, it goes down 1, 2, 3, 4. So it'll be down 4 boogers per, and it goes over 1, 2, 3, 4, 5, 6. 6 hours, right? But if we reduce this, what is 4/6 reduced to? Well, they're both even. So 4 has 2 2s, and 6 has 3 2s, so it still reduces to negative 2/3 boogers per hour. Moral of the story is this, y'all. Doesn't matter which points you choose, it's still going to have the same rise over run, the same rate. Now, the slope, here's the thing. Slope is the same thing as rate of change. Just, why are you doing that? Why is it, ew. I don't know why it's boxed all weird like that. Sorry, y'all. Here's the thing. Rate of change is the same thing as rate, just without the units. That's it. It's just the number. Whew. Anyways, sorry for the technical difficulties. It's always something, right? Let's go back here. All right, so that's how we do it from a graph. In fact, let's talk about a graph. A graph, rate of change is rise over run. That's what we just saw here. Now, on a table, we did the jumps. Y'all remember that? So the starting point, let's talk about the starting point again. Starting point is, where did this start? Well, think about a graph. The point was 0 something. Our starting point is anywhere where x is 0. That's going to be our starting point. So our starting point here in this case is 0, 4. Now, the rate of change, this is where we did the jumps for a table, right? So to get from 4 to 7, what's happening here? We're going up 3. 7 to 10, we're going up 3. From 10 to 9, went up 9. Then from x's, or excuse me, the monkeys, we're going up 1. From 1 to 2 goes up 1. To get from 2 to 5, we go up 3. So the rate of change, it's going to be the change in y, or the change in, and when I say change in y, remember that if we make a table, this is x and this is y. So in this case, x is monkeys and y is bananas. So our rate of change is going to be 3 what? 3 bananas over 1 monkey. In other words, our rate of change here is 3 bananas per monkey. As the amount of monkeys go up, the number of bananas goes up by a rate of 3 bananas for each monkey. So what is the slope? The slope is 3. All right, so here's the thing. From a table, we learned to do the jumps. Even here, look at this. 3 divided by 1, 3 divided by 1. Both of those are 3. What is 9 divided by 3? It's 3. So here's the thing. From a table, the way we find is we do the jumps. And we're going to do the change in y. That triangle is delta. It means change in y divided by the change in x. Again, in other words, we do the jumps for a table. And here's the thing. All of these things, rate of change, is rise over run, is change in y divided by the change in x. Check this out. Look, rise, what's changing? The y is changing. The run, what is changing? The change in x. Rise is the change in y. Run is the change in x. And all of this is the same thing as slope. The one thing that's different is that rate of change has units. Boogers per hour. Bananas per monkey. Whereas slope is no units. But all of these things tell the same thing in different ways. So rate of change, we have 2 ways of finding it. We should be able to find it from a graph and by a table. And rate of change is the same thing as slope, just without the units. So here's what's up. I'm going to give you a couple of points here. I want you to find the slope. So again, no units. We're going to find the slope. Now, some of you might know some formula. We'll talk about that tomorrow. But for right now, check this out. What I'm going to do is I'm going to take these 2 points and think of it like this. Think of it if we made a t-table, x and y. This first point here, this is the point 3, 5. The second point here is the point 9, 1. So all I do is take these 2 points and I stack them up, and we're going to do the jumps. How do I get from 5 to 1? Do I got to go up or do I got to go down? I got to go down 4, right? Go down 4. How about to get from 3 to 9? To get from 3 to 9, I got to go up 6. So it'll be positive 6. So our slope is change in y divided by the change in x. Our change in y is negative 4 divided by our change in x is 6. Does that reduce? It sure does. It reduces to negative 2 turds. Reduces to that. Hey Smith, negative 2/3. That looks familiar. Well, check this out. The point 3, 5 and the point 9, 1. 3.5, that was that point. 9.1 was that point. I stole them from that graph. And look, the graph, or excuse me, the slope still came out the same way, whether we did it by using the graph or by doing the tables. Let's do the next one. The next one, take the points and just stack them up. Now, last time I made a table. You're welcome to it, but you don't have to. If you just want to stack them up and do -3, 8, and then do 4, 11, go ahead and do that. So, doing our jumps. To get from 8 to 11, we go up 3. But to get from -3 to 4, now, if that's making your brain hurt like it does mine at times, think about this. A number line. Where is -3? Well, -3 is to the left. It's -3. And I got to get up to 4. So how much does it take to get from -3 to 0? It takes 3 to get there, and then 4 more. So how many did we go total? It was a change in 7. So our slope, change in y, 3 over, oh boy, here we go again. Oh my goodness. Whew. Oh boy. Come on now. No! Oh my goodness. Oh boy. 3/7. Change in y divided by the change in x. Even when I'm not there, technology is killing me. Last one, y'all. -2, 5, -5, -9. How do I get from 5 to -9? Again, if you like to think of a number line, to get from 5 to -9, I gotta go down 5, and I gotta go down another 9, so I went down, how much? Down 14. Now to get from -2 to -5, I'm gonna erase this, and I'm gonna make a new one. I guess I didn't have to erase it, but here's the thing, here's 0. Where is -2 and where is -5? -2 and -5. Did I go up and down if I go from -2 to -5? I went down 3. You with me on that? So, our slope is -14 divided by -3. Does that reduce any? 14/3 does not. However, what's negative divided by negative? Positive. Positive 14/3. Word? Hey, another way to check. Are we sure it's positive? What if I was to plot these points? -2, 5, and then -5, -9. If I was to connect those two dots, which way is that going? It's going up. Right? So yeah, it's a positive slope. Hey y'all, on the flip side of this is algebra with pizzazz. Here's the thing. This one is actually funny. This is one of my favorites. So, work on that. That is due tomorrow. Smith out!